Well, in this video I'm going to make a review of this AD B210 clone. I'm going to measure with this equipment. I'm going to measure phase noise in the transmitting and also the stability of the frequency as the capabilities to simulate, for example, or make a 5G hotspot, or could be radar, or so I will use more or less the half of the frequency that is capable to get the SDR, that is 6 GHz SDR. The test phase noise that I'm checking now with this software that I made, automatic software, is 3 GHz, and later the stability of the clock and power and all that will be at 5G frequencies, 3 GHz, 3.5 GHz. I'm using my HP 8595 I spectrum analyzer. It goes up to 6.5 GHz. Also, in some cases, a 6 GHz synthesizer, and that attenuator, step attenuator from HP also. For the stability, I'm going to use this counter XL microwave 3200. Is 20 GHz, 20 GHz counter. It has power meter as well, built in, and we're going to use also this 437B power meter with the 8481 sensor. It's a thermocouple sensor, and so will be here a resistive power divider Winchell, 6 decibels loss, 18 GHz cable, good enough, and some attenuator there, DC block here. The attenuator is at 0 because we have here 3 plus 6, 9 in the TX, SDR TX, so the test take a while because it makes 2 measurements in the offsets, 1 kHz, 10 kHz, 100 kHz, 1 meg, and it will test by sampling in zero span and also in sweep in variable resolution bandwidth. And you can see here it's being automatic. So while it finishes, or maybe I cut the video, or bueno, I explain a little bit. This B210 clone from the ITUS. It has aluminum case, CNC case. Internally it has a FPGA better than the one that is in the original one. In the original one is a Spartan 6. This has a Kintex7. Is very good FPGA and is especially good for DSP processing if you want to use the FPGA for process signals inside without any computer or Raspberry Pi or Jetson like that. So you can load your stuff and do it on board. It has very convenient IPX inputs for 10 MHz like a GPSDO, like that one or that one. Also has a GPS M10 module, and it has a GPS antenna output, so it's fine, but it doesn't have internal GPSDO like the original one. It has the GPS module, but it's only for PPS. It's not to give a GPSDO with 10 MHz reference, high quality. It's not. It's just for PPS. If you put a PPS signal externally, will cancel the PPS of the module. So it's like that. It has 2 ports, TRX 1 and 2. They can swap between TX and RX. That is very convenient, but it is opposite to this one. This is a Libre SDR clone of the Adalm Pluto from Analog Device, and this one, it has also 4 ports and has a fixed TX1 and a fixed TX1, TX2. This one, opposite to that, has a port 1 and a port 2 that can be both TX or RX, and 2 fixed RX ports. Advantage of this, can be convenient for many things and simulate some things. The bad part, and it's quite bad, it happens in the original one as well. To make this, it has a switch, and as every switch has crosstalking, it has leaks. It's not perfect isolation, so if you connect a TX like this one and at the same time a TX RX, for example, from the synthesizer to the RX, the signal will pass, so isolation is not perfect, so will leak signal from this TX to this RX, and you can see that quite easy. Oh, so that is a price to pay. So that's it. Also, it doesn't have, like Pluto ones, ARM CPU inside. It's just FPGA. For anything more of that, you need an external computer. This one has CPU, ARM CPU, so double core, 1 giga of RAM, so you can add small Linux apps. Is an advantage, but also is get hotter, and also you can see the size difference. This one is quite more convenient. It has also a gpio output. It's on the bottom. I want to show you, but you can access to the FPGA via GTAG. So, and you have some I/O outputs and inputs. So I didn't use, probably no one will use, but you have that there. It's got a flat ribbon cable, and the good thing, it has USB-C, so it can get very fast bandwidth. It has 56 megahertz, I think. I don't think that I ever reached that speed, and I don't care. Maybe someone cares. You need to, but in theory the front end is the same than the original one. You want should work at maximum like the original one. If the original one is enough, this one should be enough. One problem of this is USB 3 over USB-C. So it means even if this is a USB-C connector, you cannot put two sides USB-C cable. I didn't find a way to make it work. In this side is USB-C, and in the other side you need a USB-A, USB 3A type port. Won't work two USB-C in one side and in the other. As you see, I have here USB-C, USB-C. If I put a cable like this one, USB-C in every side, won't work. I need to have USB 3 in one side. It's not very convenient. That could be worse, could be, but you know, it's just let you know. If we compare about quality, maybe there is a couple of issues. One that is quite common, that is that the baluns, even if the SDR is 6 GHz, the baluns that it uses are 3 GHz rated. So at very high frequencies, over 3-4, the crosstalking and power loss rise quite a lot. So if you're going to work over 3 GHz, would be very convenient change the volumes yourself, which is not easy. You need some kind of microscope like that one, or magnification and some skill to change the balloons. They are very small and delicate, and they are not especially cheap. Also, it's not very expensive, but you need to take in account that. So apart of that, compatibility, sorry. Oh, this crash. My God. Well, the test won't be successful. I will pass later directly to the results. I will repeat the test and pass to the results. Compatibility, first, is not compatible with the driver, original driver from Etus. You need to change a bin file that is the FPGA bin to can load, because it's different FPGA, pues the software that you upload to the FPGA need to be different than the original. Well, pues the driver is the same and you need that file. A part of that, once you do it, will be absolutely compatible with whatever that the original one does. For example, it will work with susceptible as the original, but susceptible have not full support for Etus B200 or B210. So, and this model is better run it over the B200 in the susceptible. All right, so it will work with no problem, apart of the own problems that the software has. That is no. Also, we will work in SDR console V3. You have there. We recognize like B210. So I don't know what is this here. No clue, but you can start. Oh yes, what happened is I have it set up for this other one. You cannot have two clones with different FPGA in the same computer without change the file. So what happens is not is my fault. But worked in SDR, but you need to set up the things. I'm going to try SDR Angel. Maybe I have better luck. I didn't have prepared this, just so what space new RS device. Something wrong. I think I didn't connect properly. Maybe is that the problem. I'm going to see. Yeah, it's no. What is happening is not with. It's with adapter. It's not with. Now it's. Now it's working. It was the adapter. It's what happened when you add an adapter. So as you see, it's working in SDR console. Also SDR Angel. I don't know if I have set up SDR Angel for it, and 10 gigahertz. This cannot be. I'm going to see this one. I don't know why is appearing that there. But you can see here, it's already there. SDR B210. So you can play, and is there working? So it works with any software that would work. So I'm going to make the phase noise test it again, and I come back when the results are, because take a while, and I fail because I moved the so I come back now when the result is ready. Well, it finished the phase noise test. So we have here the results. We have a trace with the reading, sweep reading, and we can remove. This is the trace of the mini circuits SSG 601 RC. It's a synthesizer generator, and it has a very low phase noise. I think is something like minus 130 or minus 140 dBc. And what you see here is likely not the noise, the phase noise of the mini circuits, but more the phase noise of the spectrum analyzer, because it's probably larger, at least in the most part of the offsets. So we see here that is 130 is the reading at 1 megahertz. So sorry, yes, if we overlap the reading, the test is the blue one, we get the normal. They have very good phase noise in the first offset, 1 kilohertz, and but it still is better the reference. But always we are seeing that the limit is the spectrum analyzer, not the synthesizer. In any case, we see here that is giving better result the SDR in the 10 kilohertz. Sorry, in the 10 kilohertz to 100 kilohertz is giving better result than the mini circuits. This is quite nice, very good. And in this one, it's almost more or less the same. And here we had a spurious here. It was in the base of the of the carrier, and is represented here in this trace. So in this part, from up to 1 megahertz is quite worse than the mini circuits, and also if we would go further than 1 megahertz would be even bigger the difference. Also it has some spurious in the bottom, like from the PLL probably. So in the high part is very nice, in general very nice, but you need to pay something, so at the end here is where there is a not so good performance. It's a quite curious trace, and if we put the sweep here in both, we can see that it's alright. It's, you know, it has no spikes very large, maybe there a little more, but it's quite clean. It's good. So yes, in general I could say this is very good, and this is expected. Most of the SDRs that I've seen here, there is crosstalking, all that shit that make it not very nice. So yeah, it's good. And right now I'm making the test of the internal oscillator and stability of the frequency and power. Well, power is okay, but it falls quite fast above the 3 gigahertz, but they still finish with minus 15 decibels. So it's alright. Once I upgrade like this one or this one with new baluns that I have there to modify, I will make a video of that. We'll have less crosstalking and better and less losses of power. So even maybe the previous test of the phase noise maybe even improve. Well, what we see here is that it pass. This is the parameters to simulate a 5G station. So this setup is what you should to pass the settings to pass the specification of 5G, and it passed in every point. So, and as you can see, it has a fantastic ppm drift. It has a very nice drift. It's very stable. After 10 minutes it's in 0 ppm, because it's just not rubidium, but it's like a double oven oscillator. It's really nice. I did this test yesterday, I'm repeating now, and it's so good. After 1 hour will be still 0. And adding the the offset respect to the target frequency, that is 3 gigahertz and 500 megahertz, so 3.5 gigahertz. Even having the offset in account, the deviation, the normal deviation, not the drift, but the deviation of the oscillator, is having that in account more plus the ppm drift. It has a ppm of 0.02. The specification says 0.05, so it's less than the half of the specification. So this is a frequency distribution plot. This is the Allen deviation. Here will change very fast because it's in the limit of what can to do. So if there is a flow of air or something, just will change. But this is the best that you will get. This cannot be better. You see that is go up, go down. So the power is absolutely stable. It's a maximum power. It's not minus 12, it's minus 6, but I didn't put the corrections, it's not needed. So yes, just stability is very nice. You can simulate GPS, 5G, and it's very nice. Stability in the transmission and quite precise in the frequencies at 70 Hz in 3 gigahertz and a half. So it's nothing. Well, next test is we're going to check the problem of crosstalking. We are transmitting in the port 1 and nothing connected in the RX, so any leak you will see it in this port. And this is the spectrum analyzer, is what is receiving, and as you see, if I remove the generator, there is no spur. See that? It means that there is a leak there, and we can see it more clear if we synchronize with the tracking generator. Also the spurs, the crosstalking rise with the frequency, so we rise all we can. So as you see, this is the pattern of what received the receiver from the TX without be connected. There is no input. Alright, so if I now disconnect the TX there, you see that now it's receiving, it's pure receiving. It means all this stuff is crosstalking from the receiver. That is the noise floor of the receiver. So without nothing connected, I transmit in the TX and rise to all that. That is leak. All that is a leak. All that is crosstalking. It's pretty bad. If you use this RX, because it's in different paths, in different channel, will go a lot lower, but in the same channel, the TX and RX, they have a very strong crosstalking. It's a problem that also is in the original one. A second problem is I think this one is using a clone of the main chip of the analog device 9361. I think it is using the 63 version hacked to 6 GHz, like I do with this one. This one have the 63, but this claim that has the 61. That they are very close in performance when once is hacked. And what happens, if you open it, you will see that is marked like 61. But I have an original 61. This clone has a real one, and the print in the chip is different than this one. And also the texture is like if it was erased with laser, the labeling, and was relabeled, to a 61. Some characters are different, so, and the logo is different, so I think this is faking the chip. But also it's true that the price is lower, so it's like that you are paying the right amount for that chip for the 63. So that is a thing to have in account when you compare with this one, if you are deciding which to buy. I could say without can't say I'm sure, but I'm quite sure this one is using a fake chip. It's a real one, but it's hacked and relabeled. So it's a personal opinion. Maybe as it was erased with laser, maybe the isolation is worse than the original one. This one has more isolation than this one, but also this one internally have traces that separate different areas. This one doesn't. The case of this one fits with that traces, so has isolated areas, not only in the PCB. The case match that isolation, so is in the horizontal and in the vertical, so the isolation of this is probably better than this one, a part of the chip. So a part of that is a problem. The isolation it's a problem with this one, and with original. It's a known issue. Maybe with this one it's a little higher, but you can use this TX from this channel and RX from the other. But you cannot do it in susceptible if you want to do it. So you need to be sure that the software we can use TX and RX from different channels. Linear radio or can do it. So it's just normally this software the one that cannot do it. I hope one day it changes that. So, and the price I paid £160, maybe 150 with discounts before Christmas, before in Black Friday, something like that. But it wasn't Black Friday, so I used some coupons that I have. So it was £160 delivered. Didn't get customs, could be more if I get customs. So by the money, even if it's not the original 61, still is a very nice SDR. And well, the isolation can be important in some cases, not in others. So I can give a different use, but obviously I have more of one, so I can use this one in one thing, this one in others, depending the isolation that I have and the crosstalking. But obviously, and also this one has the upgraded the baluns. This one doesn't, but still this one has the, even with the standard baluns, that it has upgraded baluns as well. But when it was normally, because I did the last week, still had better isolation than this one. So if you want to use with susceptible, like a spectrum analyzer, generator, tracking generator, I would say it's better get one of these, because you can get that both the 4 channels be recognized and can work together in the same, but with any B210 clone you won't be able. No the original, no this one, no this one will be able to use the 4 ports in susceptible. So to get a good quality, you should get one of these, or two Plutos, original Plutos. There is a problem. You would say, but I get 2 of these and I use one for transmitting and one for receiving. That would be nice. You can do it with this one or the Adam Pluto, but there is a or with 2 original B210, but with the clones, because they share the same driver, but they have different FPGA and different bin file. It means that you can only use one at the same time in the same computer. So, or you use this one or this one, you cannot use both. So use 2 devices option of susceptible, you cannot do it. You can do it with this one, or use the 4 ports, or mix the ports, alternate them to get less crosstalking, but you cannot do it with them. I would say these ones are more for experimenting, and these ones maybe and developing, and maybe these ones for ham radio or use in standardized software is better recognized and better supported for different softwares. And and if you want some applications running on device, it's better this one, and if you need a very strong processing DSP, pues one of these will do better job than a Pluto clone. That's it. Is my review of this one. Yeah, is noise floor without crosstalking is you see irregular. Here have a cut at 4 GHz, which is the same that happens with the original Pluton with this one when the 9361 chip, 9363 chip is hacked to 6 GHz. And happening this one, in the original Pluton happening this one, because that I think that is not an original chip, 61. And this one that has the 61, the original one, I'm sure, and it's more expensive, it has all the way out without any cut in the noise floor. So doesn't look the same, and it's the same driver, good attenuators, good case, both CNC. So what I mean is still is nice, but you need to have that things in account. I cannot recommend something that is not what is advert. So will make me the job? Yes. Is good for me? Yes. Is for the price I can forget that they are not telling the truth, or I think that at least. Yes, but I would recommend to anyone. I cannot recommend when someone is not honest. And also I had very good experience with the shop that I bought it, and the last 2 purchases that I made there, very bad, horrible. Even with this one, very bad answer from the company. So I don't want to tell even the name to don't. So yeah, is my opinion. So I don't think that there is many more to show or to test. I hope that you find this useful. Cheers.